Oh,
like,
okay.
Like in high school.
Okay, got it. Maybe they'll unlock it for.
Oh,
Okay,
yeah,
so anyway, let's go ahead and move on. Today, we've got quadratic factor review. We're going to finish that up. And then graphs, equations, and equations and applications. I might just do equations and applications. Okay, so let's go ahead and bust up that last one, which we've been working on. You have some things coming up due. Math equations radicals is due today. Friday is quadratic function, sorry. So today's the last one from Unit 4. And then we have 3 from Unit 5. One due on Friday, one due on Monday, one due on Wednesday. And then also on Wednesday will be the exam. Units 4 and 5. It's coming up pretty soon. So I do have a practice exam for you folks to look at, which we can pass out. Maybe I should pass that out now before I forget. That is better. Thank you. So the plan is to finish up these 2 parts. We'll probably work almost entirely on factoring today. And then on Friday, we can start in on, finishing up any that we have and then finishing up the last of the handouts. And then Monday, I want to review all day Monday and a little bit on Wednesday for an hour before you take the test on Wednesday, and then you can head out.
I don't think I have this.
Oh, I must give you that one.
It's called Quadratic Factoring Review, right?
Yes.
Yeah.
I have.
Sorry, I might have not given you that one. Here's another one. Or here's one. Perfect. Good. So let's go ahead and start in on that one. So as I said, then that puts us in shape to take the exam on Wednesday. And then, like we discussed before, we will be working on Unit 6 for up until the week before Thanksgiving, and then the week of Thanksgiving we will take that Monday off.
Well, I was wondering, is there any way you can put these My Open Math dates into Canvas so they'll come up as due dates on our to-do list?
It's possible, yeah.
Like maybe just an announcement even.
Okay. I can try to open that. I just wanted to see the open. There we go. Nope, that's not that one, is it? Okay, so last class we did factor by grouping. Did we finish all of those examples?
We're on the Roman numeral 2, I think.
Okay, so we did finish all the factoring by group. Factor by grouping.
Oh, maybe the first one we only did.
Yeah, only the
Okay.
first one.
So factoring by grouping, only the first one.
Okay. All right, so let's take a look at it. So remember how these ones work is if we give them to you, you put them in order, the biggest one to the smallest one, and then these 2 group together. So I usually draw a little curve underneath them, like a little cat's face. Circle the nose, and then that part over there. So group the first part, circle the sign because the sign's important, and then underline the rest of it. So what we did here was, okay, so what can I pull out of 5x to the third and 10x squared? 5x squared. What am I left with? X. If I divide this by 5x squared, I get x. If I divide this by 5x squared, I get 2, so plus 2. And then don't forget this plus here, that's important. Maybe I'll do it in different colors. Over here we've got, what can I pull out of both of these? 7. If I pull out a 7, I'm left with x. And then divide this by 7, I get plus 2.
So you're just pulling out like a common...
So I'm factoring this group, and I'm factoring this group.
Like seeing what's divisible by both numbers.
Right.
Okay.
Now, I have sort of 2 pieces. I have this piece over here, which is 3 three things being multiplied, well, four things being multiplied. This is a 5, and an x squared, and x plus 2 being multiplied. Everyone look up. This is a 5 multiplied by an x squared multiplied by an x plus 2. Everybody kind of understand that?
So if you.
There's three things being multiplied here. 5 times x squared times x plus 2.
So it's like undoing the distributive property. Like
Kind of.
if you were to.
Right, exactly. That's what we've done. We've undone the
You
distributive
should
property.
think,
We pulled out instead of distributing in. Absolutely.
Wait, can you just go back and show us like how you got to this point? Because
Yeah.
I just don't understand like how you got this, all this stuff. on the right.
Okay, that one comes from, hold on. That comes from this stuff up here. We factor out the greatest common factors. So here, what do these two have in common? What can I pull out of both of them? What can I factor out of both? So you look and see, well, number-wise, they don't have any factors I can pull out of both. But x-wise, I can divide this by 2x, and this has 2x being multiplied as well, I can pull out. So maybe it'll help if I write this as x times x plus 2 times x times x. And what do they have, what factors? So I have two pieces. What factors do they have in common? They both have 2 x's. So this has 2 x's, that one has 2 x's.
So it's not really divided by the same thing because you can't divide 2 by 3 evenly, right? Or 3 by 2 evenly, you're just pulling
So
out.
what I'm sort of doing is
Yeah.
I'm saying, I'm going to take, this is being multiplied by, I can take 2 x's out of here, and I can take 2 x's out of there.
Okay.
And instead of multiplying them individually, like Fox was saying, I can kind of undo the distributive part. So I'm gonna put those in front and multiply those in front, x times x. And then what am I left with? Well, here's x plus 4. If I were to distribute this back in, then I'll make this x squared, so then it's a little bit.
Okay.
If I were to distribute this back in, right, distributive property,
Mhm.
and multiply those, I get x squared times x, which is x to the third, x squared times 4, which is 4x squared. So they're the same thing,
Yeah.
right? These are the same thing. I've just pulled out, like she was saying, you kind of undo the distributive. See what you can pull out of both things.
Okay.
Over here, what can I pull out of both things? I can pull out a 5, right? Because 25 and 10, what can I pull out of both of them? A 5.
Fine.
What can I pull out of both, in terms of the x's, I can pull out an x.
No.
So if I do that, what am I left with? This has to become, what times 5x gives me 25x? 5. 5 times 5x is 25x. And then what times 5x gives me 10x to the 5th? So kind of in a way, you can look at it sort of like saying, well, let me divide this by 5x so that I know, because I'm pulling it out in front, I can kind of say what should be left over here. So that would be 2, and then x to the 5th divided by x is x to the 4th. Because then when I multiply this by 5x, if I undo the distributive, I would get this back.
Okay.
So it's kind of why I divide them, because that way, because I'm saying, well, I want to know what times 5x gives me this number.
Okay.
So that's why I kind of divide by 5x to figure out what that number is. Right, because this is sort of like, so I'm going to multiply 5x in front, right? Which means I'm going to divide by 5x on the bottom. So it doesn't change, it's just, right, because 5x over 5x is just another form of 1. So if I multiply it in front, I divide it down here so that I end up with this, I don't change it. It's just multiplying it by another form of 1, 5x over 5x. So multiply by 5x in front, divide by 5x in the bottom, so that these end up being the same as what I started with. You can kind of think of it that way.
What would you do with the B in the third one?
You take it out.
So it just completely,
So this one here, what we did was we said, okay, we can pull out an 8. And I think we pulled out an 8 and an a squared and a b. So what are we left with? Negative 4a plus 1. We have to do the 1 because what times 8a squared b gives us this 1. If I don't have the 1 there, then this would, if I only did this, then it wouldn't be the same when you foiled it. It would just be that. Right, so the 1 here is important. So everyone remember that? You gotta have that 1 there, or else this would go away when you foiled it, when you distribute it back in. And what I said actually in class was, I like to have this first one be positive, so I would actually pull out negative 8ab squared. A squared b. Okay, so back to this one we're looking at here. So here, we've distributed this, the 5x squared out and the 7 out. Everybody on board?
Mhm.
So what I'm left with here is I have 3 things being multiplied. A 5, an x squared, and an x plus 2. They're being multiplied. Everybody, again, let's take a little aside here. Let's point something out. So say I have x plus 1 times x minus 2 over x plus 1. How do people feel about the fact that these two will cancel out, and this is equal to x minus 2? Do folks feel okay with that or not so much?
Okay.
Okay? You feel okay with that? So this is just a slight variation on that one. I have 3 things being multiplied. A 5, an x squared, and an x plus 2. X plus 2 is, it's together. It's, it's a piece. You can't separate them. It's not x and a plus 2. It's x plus 2 together in parentheses is being multiplied by 5x squared, 5 and an x squared. Then we have a separate group. You see that plus symbol? It's a separate group. I have a 7 being multiplied by, again, an x plus 2. So, if it were this, people would feel a lot better. If it was 5x squared b plus 7b, then you folks would feel great about pulling the b out and making that into b times 5x squared plus 7. Correct? Yes or no? If I had this, 5x squared b plus 7b, would people feel okay pulling the b out in front? Making this into 5, factoring out the greatest common factor, or pulling out the b? Yes or no? No? That's what we did. That's what we did above.
So we're still factoring again? We're not,
We're
foiling now?
we're factoring. We're factoring.
Again?
We're still factoring. So see how we pulled out x squared out of the top here,
Mhm.
right? We pulled out an x squared, ended up with x plus 4. Here we pulled out a 5x. We ended up with, I'll erase these things so they're less confusing. We pulled out a 5x, and we're left with this piece here. How do people feel about pulling out, if I had this is separate, this is just a different note. If I had this, how do people feel about pulling out the b and making this into b times 5x squared plus 7? Folks feel okay with that?
yeah, that makes sense.
Okay.
That be the PC out.
Good, so then this is just the same idea, only instead of it being b, it's x squared, I'm sorry, it's x plus 2. So x plus 2 is sort of like b. if I pull that out, I can pull it out. So I have an x plus 2 here, and I have an x plus 2 there. I'm going to pull them out. So then I'm going to have x plus 2. Sorry, let me redo that in the color. X plus 2. I'm pulling it out of this. If I pull it out of the first part, what am I left with? 5x squared. Plus, if I pull it out of the second part, what am I left with? 7. If I were to multiply, if I were to distribute those back in, oops, can't do that. If I distribute those back in, I'd get 5x squared, sorry, x plus 2 times 5x squared. And I'd get x plus 2 times 7. So you get those same pieces there. What I started with. It's just like, I mean, which you can rewrite. I could write the 5x squared in front if I wanted to. That's the same thing. Because multiplication, remember, it's commutative. And I could write plus 7 in front as well. If I wanted to as well. So it's the same thing. Yes, no? Okay.
Those other examples, I guess, are just confusing because it's not the problem we're working on for me. So I don't understand the steps you're taking to get, or why you're doing
That's
it.
why I'm trying to explain to you the steps. I'm just trying to get you the steps so that you're,
So I have no idea, like where you're adding, or subtracting, or doing, like, maybe if you can like circle what you're doing to get each next position or something. Like,
okay. If not, then I think we'll have to do it after class.
yeah.
All right, so here are the steps. First group, circle the thing in the middle. Second group. What can you factor out of the first group? An x squared. What am I left with? What am I left with? Everyone figure out what I'm left with. First, what can I factor out of x to the third power and x to the second power? X squared. If I do that, what am I left with? X plus 1. Good. Then we have our minus symbol, the nose. Don't forget that minus. So it means I need to factor out a minus whatever this is. What do I need to factor out? What can I factor out of both of these two? It has to be a minus something. What? Minus
1.
8. Good. Factoring out an 8. If I factor out negative minus 8 out of both of these, what am I left with? X plus 1. When we do these, you'll see that there's always, whatever's in the parentheses will always be this exact same thing. They'll always be the exact same. If they're not, you've done it wrong. And that's because we've set these problems up especially so they work out this way. Now, I've got an x squared times an x plus 1. I have a negative 8 times an x plus 1. I can pull x plus 1 out of both of them, factor it out of both of them. So then if I do that, I'll have plus 1. If I pull that out of both, what am I left with? X squared minus 8, exactly. So these pieces make up that part there. That's what's left when I pull out x plus 1 out of both of them. I pull x plus 1 out of here, out of this group, I'm left with x squared. Pull x plus 1 out of that group, I'm left with minus 8. So x squared minus 8 times x plus 1. let's work on the last one. I'm gonna let you folks work on the last one together in the groups. Probably better. Yeah, please. Great, so let's see what we have here. First group, circle the negative, and the last group. So what can we pull out of, what do you folks find we can pull out of the first group? 3x squared. And if you do that, you're left with 6x to the third divided by 3x squared is 2x.
Minus 1.
Yep, and then minus 1. 3x squared divided by 3x squared. All right, now next, this is a minus. That means I have to pull out a negative, or they won't match up. So what can I pull out of 30x and 15? I can pull out 15. So I can pull out negative 15. If I pull out negative 15, 30x to negative 30x divided by negative 15 is
2x.
2x, great. 15 divided by negative 15 is what? Negative 1. So now I have two pieces, right? I have this front piece is things being multiplied together. This back thing is things being multiplied together. They both have a 2x minus 1 in them. So I'm going to pull that out. And I'm left with 3x squared minus 15. Done. Good. You can write them the other direction, right? If you prefer to write them this way, it's exactly the same. Doesn't matter, because multiplication is commutative. You can write the first, either one first. They're both the same. Any questions on that? All right. So let's go ahead and take a look at factoring trinomials. It's actually more important. So this is, we're going to do a couple different options. Both of them are going to start with the AC method, also known as the diamond method. And then I'll give you two options for the second part. One will be the box method, and one will be this factor by grouping. You can do either one. So if you like factor by grouping, then you'll probably continue factor by grouping. If you hate factor by grouping, you'll do the box method. Okay? Either one's good. When I was a kid growing up, we didn't have either. We had to guess and check. That was all we had to do, which took forever sometimes. Sometimes it was really fast, sometimes it took a long time. Okay, so here, all we're looking at is, if we look at this thing here, we know that when we factor this thing, it's going to be, I hate to do it that way. Well, where it comes from is, we multiply, when we FOIL these, we're going to factor it into something x here and some number there, right? And that we know that x plus something here. We know that when we FOIL them, these two make the x squared part, and then these two and these two make combine to add up to make the x part, and then the two numbers being multiplied together make up that last part. Maybe I should change these, to make these a different color, because that would be useful. So these two pieces here, let's make them purple. Right, so this comes from whatever that is multiplied by that, and whatever the x is multiplied by the number. So what we know from that is, if we're trying to find these two numbers here, is that they have to multiply together to give me the negative 45, and to add together to give me the negative 12. So I need two numbers that multiply. So think of it like AC plus B is kind of the phrase. If you kind of remember AC plus B, you find two numbers that multiply to AC, right? They multiply to AC, and they add to 12, to negative 12, sorry. So what are two numbers that multiply to negative 45 and add to 12, or sorry, add to negative 12? Well, the easy one is negative 1 and 45, but those do not add up to 44. 1 and negative 45 also doesn't add up to negative 12. Negative 3 and 15 is close, it adds up to positive 12. But finally I get to 3 and negative 15, and that does add up to negative 12. So these are my factors here. Who's ever seen the diamond method? Anybody?
It's like that X.
Yeah, it's the same sort of concept. Right, so here I have x squared, what was this? Minus 12 x minus 45. So I always think of it as AC, A times C, plus B. So this is the one you have to multiply, right? Multiply. I'll put a little slide here, this is multiplication. So I need to multiply to A times C, A times, so what's my A? First off, folks, let's do a quick review. What's my A, what's my B, what's my C? A equals, B equals, and C equals. What are those three numbers? I want to find those three numbers. Remember, this is ax squared plus bx plus c, right? So David, what's my A? What's my A?
2x? No. X.
It's the number in front of x squared. What's the number in front of x squared?
1.
1. What's my B?
Negative 12.
Negative 12. What's my C? Eric? What's my
Negative
C?
45.
Negative 45. Good. So my A times C is 1 times negative 45. Negative 45. My B is negative 12. So I need to find two numbers that multiply to negative 45 and two numbers that add to negative 12. Right? And so that's when you just kind of, you try them. You try them out and say, okay. And what I usually do is I factor 45. So I know that 45 is, well, it's 3 times 15, because I know I have 3 15-minute spots. And then I kind of look at, if that doesn't work out, I can say, okay, well, 15 is really 3 times 5. Yeah, exactly. So I can make this, I can move with one of the 3's over and make that 9 times 5. Or I can make this, oh, that's still the same thing, it's still 15. But those kind of give me my options. You kind of, basically you can factor out 45 and say 45 is, well, I know it has a 3 in it, I'm left with 15, and that takes another 3 out of there, I'm left with 5. So 3, 3, and 5, any combination that you can do to kind of, come up with, so it could be 3 times 3 and 5 on this side, or it could be 3 times 5 and 3 on this side, or it could be, or the other ones would be 45 and 1. So those are sort of my options for factoring the 45, and either side can be negative. That's sort of how I kind of find them, all my options. So this becomes, wait, 3 times 3, so it's 9. Or I could have done 3 times 5, so that's 15. So kind of the 3 different combinations I have is 9 and 5, 15 and 3, 45 and 1, with one of them being positive, one being negative. The negative 12 means that actually, I take it back. The negative 45 up top means that the only way you get a negative when you multiply two numbers is if one's positive and one's negative. That means they have to be different signs. So the top number, the a times c, will tell you whether they're the same sign or different signs. So since the top one is negative, the only way that two numbers multiply and get to be a negative number is if one's positive, one's negative, which means I need to find the difference of them. So the difference of 9 and 15 is not going to be it, that's going to be 4. The difference of 45 and 1 is not going to be it, that's going to be 44. Difference of 15 and 3, that's going to be it, because that's going to be 12. So that's how I know it's 15 and 3. So I know my numbers are 15 and 3. The dilemma is, which one is negative? Well, they have to add the negative 12. That means the bigger one needs to be negative. Does that make sense for folks? Yes or no? Okay. So those are my numbers. Okay. So that's all we're doing in this first group, is finding out what those two numbers are. So we're going to have you folks in your groups. There we go. In your groups, work on number 1. Just figure out what the product of A times C is, figure out what B is, and then find two numbers that end up multiplying to whatever the AC is and adding to whatever the B is. So try some different ones. What was that? Oh, and then, all right, I'm going to give you folks one thing. If, heads up guys, if and only if your A is 1, in other words, there's no number in front of the x squared, then once you get to this spot, then you have your factors. So since my A is 1, that means that I can go straight to this and say that it's x minus 15 times x plus 3. You can only do that if your A is 1. There's no number in front of the x. So the first ones we're going to do, we're going to warm up with those ones. So you're going to do all ones that have, the first couple problems you're going to do next have no number, or it's just a regular x squared, no number in front of it, just a plain x squared. Not a 3x squared or 2x squared. Everybody understand what I'm saying?
Yeah.
So then you can go straight to this. So go ahead and do number 1 with your partners.